So, first off, when you look at the velocity time graph here, right? If you want to show the velocity, remember that the slope of a position time graph is velocity. I'm going to label these sort of four regions: region 1, region 2, region 3, and region 4. Hopefully for part 1, you're okay with a slope of 0 meters per second because it's a horizontal line. For region 2, we're going from 2 to 8. So we're covering from 2 to 8, which is that 6 meters? And we're doing it in 2 seconds. So you get a velocity of 3 meters per second. For region 3, it's a horizontal line. What's my velocity? 0. For region 4, right? I'm up here at a position of 8, and I'm dropping down to a position of 4. So that means I'm losing 4 meters of position in 4 seconds. That's going to be a negative 1 meter per second. Now, I know a number of you got that right because I saw a number of your velocity time graphs. So your velocity time graph for the first 2 seconds, region 1, the velocity is 0. Region 2, the velocity is 3. So I come over here. Let me see if I can turn a light on. Is that better or worse for vision there? No difference? All right. So here, I've got a velocity of 0 for the next 2 seconds. And then I've got to have a velocity of negative 1. So that's what your velocity time graph looks like for the first one. Ask questions if you have them. Then it says, hey, find the speed for the entire motion, and then find the velocity. We talked about 2 formulas: distance over time. You have to do the math right. I'm covering 0 meters here. I'm covering 6 meters here because I'm going from 2 to 8. I'm covering 0 meters here, and I'm covering 4 meters here. Distances are always positive, so it's 6 meters plus 4 meters, and that's 10 meters, and it took me 10 seconds. All right? I'm still on camera. Y'all have questions up to that point? What's the formula for velocity? It's displacement over time. Now, there's 2 ways to get displacement. You can look up here and you can just do final position of 4 minus initial position of 2. So that's going to be 4 meters minus 2 meters in 10 seconds. That's giving me 2 meters per 10 seconds, which is 0.2 meters per second. You could also find the area down here, right? And the area would give you a displacement, and it would be exactly equal to 2. Because of time, I'm not going to do that area calculation, but I'm going to pause for just a second, see if anyone has something on the front of the first page. And again, I'll post this. It'll be like a YouTube link, and I'll put it on today's lesson for you, okay? Now, the next questions. Many of you have not gotten this far, so take a quick moment and look at it. Each one is a position versus time graph. And it says rank them based on displacement. So I'm hopeful that you guys can still look at this and get it pretty quick. My position right here is not changing, so my displacement is 0. Here I'm going from a position of 2 to a position of 6. And since it's final minus initial, my displacement here is 4. Here my position, is it increasing or decreasing by 8? Decreasing by 8, so it should be a negative 8. Here I'm starting at 0 and ending at 0. So what is my change in position, even though I'm going and coming back? No change in position. So if I had to rank these from greatest to least, the biggest one that I see is B, positive 4. Then I have a tie between A and D, because they're tied at 0, and then I have C. Explain your reasoning. All right? I will leave that because we know displacement is just final position minus initial position. All right? Scooching it down. If you got a question, go. We always go final position minus initial. So it wouldn't be 8 minus 0. It would be 0 minus 8. But that's a good question, okay? All right? Now the bottom one doesn't ask you for distance. It asks you for displacement. Or excuse me, it doesn't ask you for displacement. It asks you for distance. So again, I didn't move anywhere. So I covered 0 meters here. Here I went from 2 to 6. I got 4 meters here. Here I'm covering 8 meters. And the last one is sneaky. How many meters am I actually covering? 16. So if I ask you to rank those from biggest to smallest, it looks like I'm going D is biggest, then C, then B, then A. Because we remember distance is just how far. All right, moving on. Look to the next page, guys. I've got 6 velocity time graphs. All of them have the same time and velocity values. If I want to know displacement, I have to find area. So I'm going to write that down here as my reasoning. All right? I can get the displacement from a velocity time graph by getting the area. Right? So you have to literally just quickly find areas. These two areas are going to cancel each other out, so the displacement will be 0. Shh. This is a positive triangle, and this is a slightly bigger negative triangle. So I know that this one is sort of positive. This one's kind of biggish negative. How does this area compare to this area? Can you look at it by telling from B to F? Who's got the bigger area? B. All right? And you guys that are having side conversations, could you please stop? Because I'm trying to record this so that people can look at it and not hear a bunch of noise. So I know that this guy's bigger than this guy. I know this guy's negative. I know this guy's 0. And at the end of the day, now I just have to compare. This is a rectangle. So is this. Right? Who's bigger out of these two? D is the biggest positive velocity. And if I think about, if I had to compare a rectangle to a triangle, isn't a rectangle bigger than a triangle? So what I've just done is not any math at all. I just looked at it and used my brain.
But isn't A negative?
A is negative because it's below. Thank you. Good catch. So what I want to do is realize that because that's negative, it's going to be definitely bigger than the negative one here. So I now have my ranking. D is the biggest positive. B is the next biggest positive. F is the next biggest positive. Then I've got E, and I ran out of spaces here. And then I'm going C and A. By putting these in the boxes, I'm not saying they're the same. I am saying literally it's D, B, F, E, C, A. Shh, please. Question 5. You've got a position time graph for 2 objects. You're trying to decide who's moving faster. It says, hey, B can't be faster than A. It's below A on the graph. If I'm looking at a position time graph, how can I tell the velocity? I look at the slope. Who's got the steeper slope, A or B? B is a steeper slope, so that means B has to be faster because B's slope is bigger than A's. So we would say, no, this is completely incorrect, and their logic is wrong, okay? Moving on. Is this the most exciting thing? No, I'm sorry, guys. I just want to make sure that you have this so that you have success on your partner quiz next time. All right. Here we go. I'm going from 6 to 2. That means I'm dropping 4 meters in 2 seconds. So that's a velocity of -2 meters per second. Here my velocity is 0. So I come up, I got a velocity of 0. Here I'm dropping 2 meters, -2 meters, and I'm doing that in 1, 2, 3, 4 seconds. So that's a -0.5 meter per second. So I'm going to come down, and I'm going to do that until I get all the way over to here. So I was at -2, then 0, then -0.5. Now I've got to get my velocity here. I'm going from 0 to 9, covering 9 meters in 3 seconds. So my velocity here is 3 meters per second. And unfortunately, I went off a little bit there. It should have gone all the way over here to the 7. And then I'm coming up, and I'm coming across at 3. So this is not actually there. All right. A written description. For the sake of time, I'm going to trust that you guys could say you start at 6 meters, go to 2 meters, steadily at 2 seconds, stand still for a second, continue in the same direction back toward the origin, covering 2 meters in 4 seconds. Then you're going to switch directions, and you're going to cover 9 meters, walking away at a steady and fast rate, 3 seconds. Motion map. Got to start out moving negatively kind of quick. So maybe that's this. If we had time, we'd put numbers on, but I don't. Then I'm at rest. Then I continue in the same direction, but a little bit slower. So what I'd want to do is I'd want to space these guys closer together with shorter arrows. Then I'm going to turn around and I'm going to head back in the other direction real fast, covering lots of distance per second. All right. Oh, guys, we're almost done. All right. Ask questions if you have them. I am so sorry that I am abusing you with this video here. Okay. You should be able to do this one. You start 4 meters away from your house. You move steadily 3 meters away from home in 1 second. So if I start at 4, I end up at 7. Find a delicious apple core. You stop and nibble on it for 4 seconds. So for 1, 2, 3, 4 seconds, I don't go anywhere. So I'm getting my position time graph drawn in place. A hawk flies overhead, sending the bunny steadily back towards its house, covering 5 meters in 2 seconds. So I know 2 seconds. I know I've got to go 1, 2, 3, 4, 5. And so I've got to cover 5 meters in 2 seconds. Sees a fox, stays motionless for 1 second, and then the bunny makes it home in the last 2 seconds. Okay? Velocity and motion map. I'm going to pause the video because it seems like that